Hi, Professor and everyone. Today, our group will be presenting a project we call Diagnosing Parkinson Disease using Voice Sample Data Analysis. So let's dive into our data brief. Our data set we have here, we have 26 variables, we extracted from 20 people that are healthy and 20 people that have Parkinson disease. Our project objective is to determine a set of silent variables that could be used to distinguish people from PD and from those who are healthy. So our output is indicating the variable. So our project we have four main steps. First one is data processing, second one is data statistic, and third one is the test hypothesis, and third one is the last one is correlation. So let's move on in the very first step, data processing. So in this step we want to like matching 29 column with 29 label of sound variable. After matching those, so we compute um, to we compile code to check whether data is missing value, data is redundant, or data is duplicated. So our output here is we have 0 missing value, we have no redundant data, and we have no duplicate data for 29 variable. So to conclude, after processing data, we are confident to compute the descriptive statistic. So let's move on into our code. So first one we want to like read the data and matching 29 label variable sound variable to 29 column, and one this code is checking whether data is missing value or duplicated. If it's duplicated, we print out the duplicated, and if it's not, we print out no duplicated row file. So here the code that we are compute. So we in the output it shows that there are no duplicated raw file and 0 missing value.
Descriptive statistics. After checking the database efficiency, we start to compute the descriptive statistics, describe the datasets. And this is the output, and we have to go to the code. This one we have to make the column, and we have to define data frame. And go to the bring the data frame, and after that one we have to describe the data frame. And after that one we have to draw the pictures. This is the histogram for 26 variable. After that one we have to draw the bar charts, the means between two group BD and non-BD. Now we have to run the code. Yes, this is the output. The first is the data set, and this one we have to the describe about the data, but this elect the information, so we need to export it is CSV file to see. Is it very easy? Yes, this one. We have to see the mean standard deviation, the mean 25% to 75% and the max for each of variable. And after that one, we have to see the visualize of the histogram for 26 variable. As can be seen, most of histogram are not normal distributions, but you can see this is the screw left, this is the screw right, and by model, yes, and so we have to assumption that all the 26 variables are approximately normal distributed to compute the test hypothesis. And this is the last one. This is the means between BD and non-BD. Yes. When we look at the diagram, the mean between true BD and non-BD is clear to significant difference in true variables, including Chester 2, 3, 4, 5, 6, sigma 11, harmonicity 14, and but to conclusion the meaning of the difference between two groups, we have to conclude independent t-test in the next step.
My part is about the t-test hypothesis. Non-hypothesis, there is no difference between two groups, PD and non-PD in each variable. Alternative hypothesis, there is difference between the two groups in each variable. Now let's check the coding part. First, data processing. Create a new table with labeled columns. Then separate the data with PD indicator 0 or 1. Then identify the most significant features with the t-test two-sided. If p-value is less than 0.05, we reject non-hypothesis. Otherwise, we don't reject non-hypothesis. Then we print the result and the significant features. So about the conclusion, we don't reject non-hypothesis for 10 variables. Schema 7, Schema 8, Schema 9, Schema 10, Schema 12 have harmonicity 15, pitch 19, pose 21, pose 22, pose 24. It means that there's no significant difference between two groups, PD and non-PD. There's enough evidence to reject non-hypothesis for 16 variables, Jetta 5, Jetta 2, Jetta 3, Jetta 4, Jetta 5, Jetta 6, Schema 11, harmonicity 13, harmonicity 14, pitch 16, pitch 17, pitch 18, pitch 20, pose 23, voice 25, voice 26, voice 27. It demonstrates that there is a difference between two groups. Therefore, we can use these 16 variables to identify who is Pakistan or not. And about the limitation, among the 16 significant features, there's only one normal distribution. We have to accept this result with the limitation. This is because sample data is not normally distributed. Therefore, the power of the p-value may be limited. If we need to prove a formal conclusion with a confidence interval, we must increase the sample data value.
Based on the results of previous t-tests, we have identified 16 variables that reject the null hypothesis, suggesting no difference between the two groups. From this one, we will run the code by using Python to run these 16 variables to create a correlation matrix. And the next step is generating a box plot, and the last one to create a heat map. And after we execute of our code, the results are as the following. At this one, I will show you displaying the correlation matrix of the 16 variables. And the next one is going to be box plot diagram. And the last is going to be the heat map diagram chart. The box plot diagrams reveal the presence of the average, minimum, maximum, and median values and some outlier, illustrating the distinction between data of PD and non-PD groups, and providing us with a comprehensive understanding of the data distribution. And for this slide, it generates correlation value on the right side, while a heat map diagram is displayed on the left. This element is illustrate the correlation matrix among the 16 variable features, helping visualize these relationships. The color within the heat map indicate the degree of correlation between variables. Values closer to 1 signify a positive correlation, while those closer to -1 indicate a negative correlation. For example, jitter 2 to jitter 6 has a strong positive correlation with each other, while harmonicity 13 and pulse 23 display a negative correlation with most of other variables. In summary, our group organized the data by checking how data was split across all 26 variables, checking missing values, normal distribution to ensure that data was good enough for running t-test analysis. From this, we can identify 16 variables that really stand out in telling the difference between PD and non-PD groups. Also, the box plot and heat map diagram gave us a deeper look into how these variables are connected. And that concludes our presentation. Thank you very much for your time.